All right, we talking about precision, right? And how precision relates to the number of, is entirely based on what's on the display as I'm defining it. So that this device may have 0.1 degrees C of precision, and this device may have 0.01 degree of precision. Sounds good? Okay. I want to consider a situation where the actual temperature, right, the true temperature is 37.52, and it goes on and on. Right? It's some value, but it's 37.52 degrees C. I use this device, right? This device here. So we'll call this device 1. And I look at its what is indicated. I'll put indicate. Indicated, right? On the display. And this device shows me 37.5. Because that's all it can. But as we've discussed, that is not necessarily a problem. It might still be useful. Okay. But I got this device, right? A little fancier. So this is device 1. Let's look at device 2. Oops. And it reads 32.16. Actual temperature is 37.52. This one reads 37.5. This one reports 32.16. As I have defined precision, right, and I gave you a very specific operant definition, right, which one of these devices has more precision? There you go. You're saying device 2 has more precision, but you're using this other word, it is less accurate. So we need to define something else, which is accuracy. How accurate a device is. And this, once again, I'll define it based on what's on the display. I'll say, how close the displayed, there's this word again, measurand value is to the actual value. There's that word, actual measurand value, to be clear. Because we have the actual measurand, and then after some performance by the device, we have the display of the measurand. And there is no guarantee that what's on the display, all right, is correct, right? Why not? Well, we'll get into the many why nots. Okay, we'll get into the why nots. Let's assume that this is the case. You're saying that's not very good. Now, the actual temperature, to take it one step further, the actual temperature changes again. It is now 38.10. This device here reads 38.0. And this device here, let's see, it's going low, reads, it's higher, reads 34.01. Once again, this device remains the winner as regard to precision. It always will be. But it is not the winner in regards to accuracy. Okay. Devices with more precision are not necessarily more accurate. You think they might be, right? You think that if you would think that this device, right, by having showing me to the 100th of the degree C is more accurate, but that's not a guarantee. So when we are designing instruments, when we are using instruments, we need to be very aware of these differences. I would hope so, right? I would hope, for example, that if you're under medical care, right, and a nurse is taking a reading, right, from you, right, will that nurse understand that the precision is not necessarily the accuracy? Or maybe she won't, right? Maybe there is a cost to giving too much precision, other than confusing the dad, right? In this case. So, yeah, you had a question?
Yeah, are they inversely related? Like, is it that you can be, the more precise you are, the less accurate you may be, or the more accurate you are?
Yeah, your question is, are they inversely related in that the more precise you are, the less accurate you are? No, I get the intuition. No, based on how I'm about to define accuracy. Because I didn't give you, I understand your intuition. But if we follow this definition here, well, how off were we here, right? Let me try to add it a little space here where we can talk about the error. I'll try to use a color here, like orange. Let's talk about put it sideways so it fits. The error. The error is how far we were, right, from the actual value. In this case, right, I'm going to put the error at 0. Even though, right, there is a level of detail that is missing here, right, the level of detail that it reported is true, right? In this case, hopefully it's clear because we're using different colors here for error. In this case, I would put the error as 0.1. And the error, by the way, is in degree C. Right? Using different colors to make it clear. Let's talk about the error here. Well, in this case, the error was, well, we're about 5, right? 5.3, 5.4 off, huh? 5.36. So let me just leave it here. Let's say it's greater than 5.3, right? This is the error in degree C. And in this case, right, we were at 4 degrees off, roughly 4. This device is giving a reading to within, based on this experiment, right, to within 0.1 degree of the actual value, which is roughly where its precision is, right? And I think that's pretty good. We could talk a little bit more about how because there's rounding errors here as well, but I don't want to deal with that just yet, all right? This device here, while marketed and looks better, right? And they added an extra level of precision here. In this case, is off by 5.3. In this case, is off by 4. Right? It is off by quite a few degrees C as far as its accuracy. Right? So now we have to define the accuracy of these instruments. Right? Yes?
This is more so like a practical question, you could say. Well, how do you deal with like an instrument where the accuracy is constantly varying?
So the question is, how do you deal with an instrument that the accuracy is varying? Let's deal with it. I'm going to squeeze it in here. we go back to 37.52. Just the same initial measurement we had here. Draw a line here. It's getting very busy. Oh, should give myself more room. All right. We go back to this device, and now we measure 37 point, let's do 6. And on this instrument, we get 30.00. Now this is what we're measuring, right, on the instrument. How far off were we in this case? Well, in this case, we were once again around 0. The error was about 0.1 degree, right? The error is how far away we are from the actual. In this case, the error was, wow, now we are at, right, 30, 37. It's great. It's like 30. The error gets up to 7.5. Now, this brings up another issue of repeatability, which we're going to get to. But let's just look at it this, okay. So now here, well, I'm comfortable saying, right, just looking at these numbers, that this seems that it's accurate within 0.1 still. Nothing's broken that rule, right? But here, wow, it was off by 7.5. So now, I want to sell this, and I want to tell people that it's better than this. So I'm going to say, listen up. My device has an accuracy of 0.1 degrees C. And this device has an accuracy of, right, I have to say a number, right? There is no hard and fast rule of how you would determine accuracy, how you would determine the report accuracy. One option may be to report the worst. It's accurate to 7.5 degrees, right? That's the error. Now, it could be better, right? But that's one way I could report it. You could try to report it as like the percentage of the reading, but I think it's a simple way to start with. To just report this is the size of the error. Okay. What do we do with this information? Let's just do it right here. Let's go back right here. I'll do another little experiment. Let's go back to oh, you know what? Let me just create a new experiment right here. All right. We have two devices that we were working with. Both devices are designed to measure temperature. We have decided that this device is accurate. Its accuracy can be described by giving it the number 0.1 degrees C. We suggested that this device, right, has a worse accuracy, that we will describe it as 7.5 degrees C. 0.1 degrees C, 7.5 degrees C, right? This was the accuracy that we are assigning to these two specific instruments. Okay. Now I'm going to go and I'm going to measure the temperature of something, but I don't know the actual temperature anymore, right? I mean, how would I know that, right? So I'm going to now just measure the temperature with both these devices. All right. With this device here, I measure 38.7, right? This is the reading of device 1. It's 38.7. Now, if I know that the accuracy and the precision, well, I know the precision because it's 0.1, right? That's the precision, not just what's on the display. But I know the accuracy is 0.1 degrees C, right? What does that tell me about the actual temperature? What do you think I could infer? So I know that the actual temperature may not be exactly what this says, right? It could be different, right? That's what we saw before, right? I'm trying to figure out what the temperature here is. Can I say anything? I mean, for example, do you think the actual temperature might be 30 degrees? No, right? Because it's more accurate than that. What would you say is the possible range of the actual temperature? Right. So I'm going to put a guess here related to this. The guess was, as you put it, purple. It might be 38.6 to 38.8. Because if it's 38.8 and the error was 0.1, it might have read as low as 38.7, right? Worst case scenario. If it was 38.6 and the accuracy, sorry, I said precision, the accuracy was 0.1, if it's 38.6, it might have read 38.7. So in both these situations, or also, by the way, if it's 38.7, it could read 38.7. But it's somewhere in this range. Is this a problem? It may not be. It's still useful, right? Hospital, right? Hospital, even if it's not quite accurate. Now in this case, let me put it in a different row. It reads, 48, let me do it the same. It also reads 38.70. Now, the precision is a lot higher, right? This device is projecting a lot more confidence, right? 38.70 even, right? Like not 38.71, not 38.69, right? 38.70. However, we know that the device has an accuracy of 7.5 degrees C. As a result, if we were to guess what the temperature was here, well, we would have quite a range, right? We would have roughly, right? It'd be something like, 31 degrees, right? All the way up to, roughly, right? 45 degrees. Precisely, I would subtract 7.5 and I would add 7.5. But it doesn't matter, we have a really big problem. Even though it's giving me this precise reading of 38.70, right? I actually don't know if it's 31, right? Which would be very cold physiologically. 45, which would be fatal. Degrees Celsius would be fatal physiologically. It is really not a useful device for this application, right? Maybe if the purpose of this device was to measure, I don't know, the temperature of your muffler, maybe it doesn't matter, right? At that point, it just has to be in some broad range. But for what we want to use it for, it is certainly not useful. Every biomedical instrument comes with a precision because there's always a display at some point. Someone's looking at it. Every biomedical instrument that's used to measure has an accuracy. There is no such thing as an instrument with 0.0000, like just perfect accuracy. And we can talk about why that is, but it does not exist. So therefore, when you design biomedical instruments, you do not design biomedical instruments to have perfect accuracy. It's not just an unreasonable goal, it's a very dangerous goal. It doesn't make any sense. You design biomedical instruments to have a certain level of accuracy that is prescribed or determined based on their use. And also based on their use, you can decide on the associated precision. It may be okay to have more decimal points on your precision than your accuracy. It might be. You may want to have less. Those are very application-specific decisions, right? But that is, so that's the essence, right, of precision and of accuracy.